Okay.
I know that there's business. I don't want documents. I told the parents was like, I should just tell them I will start it soon. Oh my God. Like, if I don't allow driving, I was like, I wouldn't even agree to He was like, I was like, if I don't have like conference, the best. It's not. He was like, are you sure you want to find out for your master? Oh yeah, me and number 2. Do you know what's better to do presentation?
You go to lab, you do. I can't do it. Madam,
Who did that over there? I watched video yesterday.
I didn't watch.
I watched
No, I watched video, but I'm not that.
I didn't want very chilled Spider-Man series.
Yeah. It's just more content I did.
I did see.
No, it's on the.
Not on the last one.
It's on that video.
That forensic investigation one.
About anything.
There's only 3 videos. The first 2 is the last one.
That forensic investigation.
One. That's
the one.
Like 15 minutes. No. You don't watch I'm in class. I just watch I in summarize.
Stomach content. Wait, is it the one where someone was poisoning?
The one where you kill his wife, kill his wife, or lie about the time. They not check her stomach and realize that she must have her food not digest. So as soon as she ate, he must have killed her.
It's O.J. Simpson. It's O.J. Simpson.
No.
Then I didn't see
the last video, forensic investigation one. That is video. Yeah, that's one. It's like
please continue.
The first investigation one is like 6 videos. The first one that plays is about that husband and wife. We watched it in class now. That you uploaded. You know, I was shouting that someone content on the mood. I said no, upload it.
Okay, I guess we can get started. Okay, attendance. Present. Next. Next.
Present.
Next. Misha. Brandon. Coming? Brandon, yeah. Kella. And Trisha. And okay, so let's get started. So last time I asked you to get ready with the last, right? You run this? Are you ready with control?
I'm getting an error. I think I got an error somewhere. So I'm trying to go back. But I really copied it.
Just copy. So I'll. So just open your R, open your new R script, and the first line is just the same line, author, date, and I'll just copy the things over from my last script, and I should, if I run this, I should not have any. Is your data still present? Did you set your working directory? So I'm just copying exactly what I did last time, and I should not have any issue.
Yeah, I'm
Yeah.
gonna see you want to.
Yeah. So if I run this, and I don't get any error. So I'm ready with my treatments and control. Okay, so any issues? So you should be ready with your treatment and your control variables. This is just what we did last time. Make sure you have your data in the same directory, same folder as last time. Yeah, copy and paste it.
Keep from crying.
No, but for real.
And how they gonna have a meeting here in spring?
She changed it's Thursday.
This Thursday? Still can't come. Everybody should.
I can't say that. I'm like,
So you actually have to send out an invite on Tuesday.
Exactly.
So I won't be able to make it. I will show up. I wouldn't have to work.
Yeah.
Yeah, true. Thank you.
Great time.
I know that.
So I'm going to like, oh,
Oh, it's mandatory. It's again if you.
Okay, any error? Good. Okay. So we should not have any error. We're just rerunning what we did last time. Read Affy. Yeah, that's fine. Next. Copy, paste. Yeah. Just run everything in.
Oh, like the iron.
Yeah.
Should we complete the box?
Yeah.
Like, should we omit like?
No, you don't have to make a box. Yeah. Good. All right, so you should have your treatment. So I just consider my first two files, right? So first cell file and second file as a treatment, and then the next three cell files as my control. So I have treatment, and what have we done in this treatment? Line 30.
Send it to the thing called treatment.
Yeah, and then what we did here?
Apply.
A log, right? So we did a log transformation on these two samples. And the same thing if we did a log for these three samples. And we just stored first two data, log transform data in treatment, and next three log transform data in rows. So that's what we did last time. So now if I just do head of treatment, then you can see that that the rows are your sample names, right? So I have two samples. So the rows are my sample names and columns are my genes, right? Gene names. So you have n number of these gene names as columns, and the rows are my samples. So I have a question. What should I do, or what function should I use to switch the rows as columns and columns as rows? Okay. Yes. We did this. What is that function which does the row column transformation?
Comma, right?
It's just one letter. Yeah. T, and what does T mean? Any guess?
Transfer.
Transfer?
Or did you say T or C?
Yeah, T.
Oh, transfer.
Transfer. Not really. What does T means? This function, it is T, right?
Transform.
Transform. Close enough, yeah, that's good. Transform. Any other guess?
Transfer.
Transform, transfer.
Transformation.
Transform. I'm not sure if you came across this word.
Transport.
Transpose.
Have you came across this word before? Transpose. Okay, guys. So do you know this word, transpose? Right, what does that do?
Right.
Yeah, it just flips things, right? It just flips things. So if it's like if you have so right now we have samples S1, S2, and then we have gene 1, gene 2. So transform will do gene 1, gene 2, S1, S2. That makes sense?
And why would we need to do that?
Because normally if you want to take a fold change, this is how your data matrix should be. Because the next thing you want to do is take a fold change, right? Fold change for treatment and control. Right. The next thing which we discussed is you want to take a fold change. So to do a fold change, you need to have genes as rows and samples as columns. That's the reason we do it. Okay, are we good? Do you understand? I'll ask this question. What is transpose? And if I give you a input data, if I give you an input data, what will transpose function do? Right? Switch the columns and rows. That's the only thing. But you have to. So you just have to tell me like, how would your transpose matrix look like? So what's the error? Yeah, that's fine.
Can you say that again? Because I couldn't hear nothing nor see anything.
Right. Give me a minute. Head of treatment. Okay, so transpose, right? So that's the word is, this is the word here, right? So transpose, this word here, it will switch columns to rows and rows to columns. That's it.
Are we gonna keep our title?
What?
We're gonna change our title to.
So okay, save the file as March 8. Title is same, just change the date. February, change the date for this today's script, March 8. Okay, title is same, everything else is same. And this is just the last, the script from last class. So everyone has the treatment and control variables, right? So the next, yes.
So, I just want to ask, in this our document, shouldn't we add the head treatment before the transpose?
Okay, so I haven't yet done transpose. This is just a comment here. So I just made a comment, a note of what is transpose. What does transpose mean? So now we will do switch. With
No, I understand what I'm saying. Like we did the head.
yes.
The head treatment. I'm just saying, shouldn't we just add it before we?
I just wanted to show you how the data looks, so you can skip it. Yeah. So head treatment. So I did this just because I wanted to show you how this data looks and why do we need to do transpose, right? So now we will do transpose. So what we should do now is next comment. Perform transpose so that samples are your columns and genes are your rows. Right? So now what I will do is I'll just copy tree treatment transpose function is T treatment, and after treatment I'll just make a note of underscore T. So I know that this new variable here is transpose variable. The same thing I do it for control. Control T control underscore T. Now this should do the flip. This should do the flip, and then we would be able to see that change in the new variable, right? So I'll just run these two statements here, and let's see what it does. Now, if I do head of treatment underscore T, right? You see the flip?
Yeah.
That is what we need. Any errors? Good.
I have an error.
What's there?
It says error in H.
Head. So No error. Do you have any error here? Misspell. It's a small HEAD bracket, and you have treatment underscore T, right? So we are making a new variable called treatment underscore T. You didn't do a run score yet. Did you run it?
Yeah.
It's not gonna-
Treatment, control T. This looks good. Let's do control C, control V. And now you do set of treatment underscore T.
Oh.
Because this is a new variable. Better? Good? No? Yeah, then we do head of treatment underscore T. So treatment underscore T is the new variable. Underscore cap. Just press up arrow. Underscore, yeah. Yeah. Good.
Yeah.
All right, any issue, right? Control not found. So yeah. So yeah, try to be like minor spelling. Kind of treatment underscore T. Okay, good. So we just did a flip for rows and for columns. And so why do you need this, right? Why do you need it? Because this is the matrix, right? This is a matrix for getting a fold change. So the next thing is we're going to get a fold change. So to get a fold change, the ratio should be for these rows on the genes, right? The genes needs to be rows and sample names should be columns. This is like the matrix for the fold change. So we did transfer, right? That's the reason. So remember this format, right? So if I give you a question and if I give you like a matrix with samples as rows and genes as columns, then you cannot take a fold change unless you transpose it. Okay, so the next thing is we want to take fold change. So if we remember what we did or what we discussed for fold change, how to make a fold change? Division or subtraction. So let's do subtraction, right? Just random. Let's do subtraction fold change. So how do you do that? How do I do this here? A subtraction fold change. A subtraction fold change. How do you do that? No? How do I take a subtraction fold change for treatment and control variables?
Like how we did the log portion, you can take log out.
Log is done.
Right.
Log is done. So now we need to take a fold change, a subtraction fold change.
She was saying like.
You can do.
Would it be a bad?
Can subtract the control.
Subtract the control from treatment. So what I will do is I'll just do treatment underscore T minus control underscore T. That's a subtraction fold change, right? So I have a very tricky question. So if I do that here, right? If I do this here, if I do this here minus this, do you think it will work? Answer is no. And the reason would be?
It's not lined up towards
It's not lined up with what?
each other.
That is very correct. Can you describe it a bit?
I really can't.
No. Anyone? It's not lined up. It's the dimensions are not correct. Can you give me more explanation why it may not work? You can see this code here, and if you can
You have
figure
to list them out, maybe.
less.
List them out.
It's not lined up. Dimensions are not right. Exactly, right? So okay. So treatment has 2 samples. Control has 3 samples. What?
We don't have 10 files.
Yeah, so okay, so if you have 5 and 5, it may work. But in my case, I have 2 and 3. So dimensions are not right, correct. So it is going to complain for me, right? But even if it's 5 and 5, and even if it works, you still have to do one small step before taking a fold change, right? And that is taking an mean, right? Mean or average, right? So even if it's 5 and 5, you still have to take an average. For me, definitely I have to take an average because there is dimension difference, right? So one has 2 samples, another has 3 samples. So the next thing which you want to do is you want to take mean for my 2 samples and mean for my 3 samples. Make sense? All right, so the next thing. Okay, now we have transposed it and we want to do fold changes. I'll make a comment here. Comment. To make fold changes, we first need to take means. Mean. What's the other name for mean? Average. For treatment and for control samples. Now, let's do this. So now we have to use a function. So to take row means, right? So you have to take row means. You have to take the means for each gene, right? Rows are genes, right? So you have to take row means. So to take row means, there's a function called row means. So the function is row, M is caps, MEAN. And let me try this first. Treatment T, and I can call it as transposed and mean. Something like this. Row means treatment T. Let me see if it works. Head treatment T mean. Yeah, that works. Okay, so do this and then I'll explain you what we did here. Control T mean, row means, Control T.
The M on the means is capital, right?
M is caps, yeah. I'll run this. head and head. Okay, both look good. Okay, that's it. That's how you take row means. Okay. And make sure you type correctly, right? So if you make like one letter mistake, cap small, it gives an error, and then you just try to figure out, wow, what's an error. So make sure everything looks as what I'm doing. And head is something which is used to quickly check what has happened, right? So that's the reason of using head. So I do things, then I do head, I see what has happened. So that gives me a quick check. Good, okay. All right. Okay. Good?
No.
No?
Got everything up there correctly, but
What is the
it's an
error?
I get an error once I run my control.
What is the error?
It says error in H, simple error in evaluate the argument X.
Are you using the same sample? Yes, because Control D. Wait, there is nothing Control D. So this here, this is a gap. Gap now. control T mean should be okay. So now we took the means. Right? So what we did is right. So what we did is we just so mean function, it will, so you have like sample 1, sample 2, sample 3, and you have gene 1, gene 2. So mean function will give you, it will just take an average for this value, and you will have like some value there. And then you will take an average for this value, and it will have some value here, right? So you're taking an average over the samples for each gene, right? So you see that you end up with like one value for each gene, right? So that is what we did with the average. So every gene here has one value. Every gene here has one value. Every gene here has one value. That is what the mean does. So now we have means for treatment and means for control. So you just have one value for treatment for each gene and one value for control for each gene. Now we can take a fold change or the subtraction, right? So next thing we're gonna do is we're gonna get the subtraction fold change for treatment over control. And how are we going to do that? Just subtract, right? Subtract this, subtract treatment minus control. And this should do it. So we'll have fold changes. Let me run this. And I do head fold change. That's all. Okay. And okay, and I think I did mention this last time, how to understand these fold change numbers, how to interpret these fold change values. Do you remember? Mm-hmm. So fold change will range from 0 to infinity positive and 0 to infinity negative, right? So more the value, more you say up regulation of that gene, less the value you say down regulation of that gene, right? So the fold change here, these numbers here, do you have these numbers, all of you?
No, I'm trying to.
Yeah, run it and get these numbers first. It may be different, but what? 0?
Yeah, that's correct.
Okay. Let's see. Yeah, that's exactly what you want. Still 0. Fold change is treatment underscore mean minus. Where is the treatment? Yeah, this is your treatment. Yeah, because your control is same as treatment. That should not be the case.
The value is actually the same for the two different.
You are reading the same file.
No, they're different files.
Different files should have different files.
They're all under the same platform ID.
This file name is different, so it should be different than this, right? Head of frequent is this. Different. 2.044, no, same. 1.65, 2.01, 2.1.
That is using this so I will control.
And control. One 1.057, 1.11. Control C, head treatment. So for control, you have 1.05, 1.11, 1.05, 1.11. It's different.
Yeah, so I don't know. After this,
Treatment and control is good. These two are good. Next thing we did was we just yeah.
thank you.
Good.
Still can't hear.
Okay. Voltage not found. So 320 not found. Means S. Oh, probably that's fine. That's fine. That's fine. That's fine. That's fine. Here. Means, right? Means. Okay, good. Good. All right. So now we have just taken a fold change. So fold change. So we were expecting just one value for each gene. So each gene. So this here is an ID, which is a gene ID. This here is an ID, which is another gene ID, right? And we have all these gene IDs. So what I want you to do is, okay, so far, so like I feel you should be fine. The next thing which we want to do is we want to look into these values and select some of the upregulated genes and some of the downregulated genes. So any gene from this list which has a fold change of more than 2, right? Number 2, that would be called as an upregulated gene. Any gene which has a fold change value of less than -2, that would be called as a downregulated gene. So we would have to select some of these genes which are upregulated, downregulated, and then we will look into what those genes are, what are their functions, what are the pathways, right? So the assignment from this class is, I want you to export this list of genes and these values as a CSV file. CSV file. So assignment. Export variable fold_change as a CSV format file with name fold changes dot CSV.
When we are uploading this on GitHub, we should upload it as a CSV file.
What? No, I don't understand. What are you saying?
So it's not also saved on our computers as an R file.
Yeah, so that you have to upload after the class, R script. But the assignment is, you have this variable, right? You have the variable called fold_change, right? You see this variable? This variable has this data, right? So you have genes with these numbers. So you want to write this variable into a CSV file. You have to export this variable as a CSV file. Yeah, it's difficult, but I want you to just.
Like if there's a step or like a procedure.
So what you have to do is, okay, hint, and listen, look, just see this carefully. I go on Google, I type write CSV in R. Hint, write CSV in R. Enter. And probably if I look into let's see, I'll also give you the link with an example. Yes, this is your answer. You have to just change the variable names. That's your hint. So just figure out now. This is the hint. Okay, so that's the thing. You have to read, and then you have to understand that statement, how that works. It just takes in 3 arguments. First argument would be your variable name, which is fold_change. Second argument will be your file name which you want to write, which is fold_changes.csv. And third argument would be your header or row names, right? So those are optional, but you should have at least 2 arguments. Once you run this write.csv function, you should have a CSV file. You know what is CSV file, right? You know what is Excel file? So Excel is .xls, CSV is .csv, but it's just the other form of XLS file.
For us to, do we have to write this whole program from beginning to end before we can export it?
Exactly, yeah, because the variable, don't close your R now if you're like not comfortable to run it again. So you have run it everything. You have this variable here in your R. It has the data, so you don't need to rerun it again. You just have to use that write.csv function on top of whatever you have run so far.
So right _CSVDF and then put the fold change in there.
Right, this is
we have to do like the directory thing where
you try just giving the name and see where if it can export. Try giving
fold change.
fold changes.csv.
Okay, so
What should be df?
right
what should be, instead of df, what should be your name here? Instead of df, it should be, it should be the variable name where you have stored your data.
So CSV and then CSV
Bracket.
then fold change.
Yeah, this name here, variable. Instead of df, it should be fold underscore change. Then you should be, then it should, then you should have your CSV file name. All right, so I will let you figure that out. And if you have any questions, you can email me.
So when I do the little arrow thing, and like, would it be in the front part and be called
You don't need anything else than this. Okay, so I will stop here.
okay? What I do?
What you do is you don't need any of this. So,
I can copy and paste it.
I see, I got it.
Oh, okay.
the variable this is your file name. It should be into have another argument.
So I'll just do head.
You don't have to do anything. No, it's done. You have file somewhere. Search. Have file somewhere. Search. Here, it's in document. Right? So yeah, I see it, right? Gmail. So don't show this to us.